watching Damn Science.
In this video, we will discuss the IGCSE paper of May-June series paper 6-2 and we'll also discuss the important tips of how to solve paper 6. So here is the question paper 6-2 of May-June series of IGCSE Chemistry 0620 code. So the first question says that sodium hydrogen carbonate decomposes when heated and the products are solid sodium carbonate, water and carbon dioxide, and the diagram is given here with the apparatus. Now the first question A says that name the items of the apparatus labeled A and B. A is labeled to the tube, so we can write it as a boiling tube or a test tube. I'll write boiling tube here because it's the boiling tube which is generally used for heating the contents of an experiment, so I'll prefer writing boiling tube. The content B is here, so B is an inverted measuring cylinder, so I'll write measuring cylinder. That is the apparatus B, measuring cylinder. Let's go ahead with the question B part of the same question. It says that when sodium hydrogen carbonate was heated, a colorless liquid collected at the point marked X and suggests the identity of the colorless liquid. Now let's have a look at the apparatus again. It shows that the X is labeled here and there is a colorless liquid here. Now if we are heating sodium hydrogen carbonate, then one of the product is water, so this colorless liquid should be water. So I'll write that the colorless liquid should be water because that's going to condense at the slanting tube, so it should be water. On the diagram, draw an arrow to show where the apparatus should be heated during the experiment. So if we have a look at the diagram, I would say that the heating should be done directly at the place where the compound is placed. So I'll put an arrow here. This is the main arrow which will be pointing towards the solid sodium hydrogen carbonate. So this is how we'll add the arrow. State an observation that would indicate that the sodium hydrogen carbonate had stopped reacting. Now if you have a look at the diagram, we can see that when the sodium hydrogen carbonate was heated, here there are bubbles being produced. So here are the bubbles. So when the reaction gets over, the bubbling will be stopped. So we can write here that the bubbles are stopped producing. The bubbles stops. So when we write bubble stops, it says that the reaction is completed or the sodium hydrogen carbonate has stopped reacting. Next question. It says that explain why is it important to remove the delivery tube from the water as soon as the heating is stopped. That is the tube which is there inside the water. It's necessary to remove it exactly after heating, immediately after heating. Now there are two reasons and it carries 2 marks. So we need to give 2 valid points and explain why it is done. So the first point I'll say is that the tube might crack if we don't remove out after heating. So this is how we write, to tube might crack, or you can write to avoid cracking of the tube, that is the boiling tube. And the second point is that the water may suck back inside the tube. So to avoid the suck backing of the water, it is important to remove the delivery tube from the water. These are the 2 points we'll be writing. Now the question 2 started. The question 1 was only this much. Now you can pause the video and have a look at the question and read each and every part of the question. Let me go ahead without wasting time with the other part of the question. Here is an experiment which shows that the burette diagrams are given and complete the table for the experiment 1. But yes, I'll just give you a brief idea what's happening here. Here we are filling up the burette with the dilute hydrochloric acid and then we are adding 5 drops of 2 indicators here, and then we are titrating this hydrochloric acid from the burette with the two types of solutions, K and L, which is sodium carbonate, and this is how we are going to perform the experiment. So this is a summary. Now if we go ahead with the part A, says that the burette reading at first color change. Now here it's given the burette reading at the first color change. We can read it is exactly 12. So we can write it is 12.0. I would say it is better to write 12.0 centimeter cube. Now final burette reading at the second color change in the centimeter cube. So burette reading at the second color change. Now if we can see that here it is 22.4. So I'll write it as 22.4 centimeter cube. Now initial burette reading is given here, which is 1.6 here. So we'll write it as 1.6 centimeter cube. Now volume of dilute hydrochloric acid added for the first color change. Now here, to find out the volume for the first color change, we need to find out the difference of these two. We need to find out the difference of these two readings. That is the difference of the initial reading and the difference of the reading of the first color change. So the difference between 12.0 centimeter cube and 1.6, that's the difference between the first reading and the initial burette reading. That difference we're going to find out for the volume of the hydrochloric acid for the first color change. And the difference is 10.4 centimeter cube. Now the total volume of the dilute hydrochloric acid added for the second color change. So now here we are going to find out the difference of the second and the third reading, that is final and the initial. So if we subtract 22.4 and 1.6, we get 20.8 centimeter cube. So these are our burette readings, and the filling up of table which is there, we need to do that, complete the table for experiment 1. So these are the filling up of table from the burette reading diagrams which are given to us. Now the experiment 2. Experiment 2, here again a similar thing is given, where the burette reading at the first color change is given. The burette reading for the first color change is given here, which is 19.7. So I'll write it as 19.7 centimeter cube. Final burette reading at the second color change, here it's here, and it is 35.3 centimeter cube. Now initial burette reading is 4.1. So I'll write it as 4.1 centimeter cube. Now volume of the dilute hydrochloric acid added for the first color change. So as usual, what are we going to do is find out the difference between the first and third reading here, which is 15.6 centimeter cube, and then the total volume of the dilute hydrochloric acid added for the second color change. So again we are going to find out the difference between the second and the third reading, which is 31.2 centimeter cube. So this is again the completion of the second table of our experiment 2. The next sub question here, it says that state the color change observed at the end point when dilute hydrochloric acid is added to the methyl orange in the alkaline solution. So here the color changes from alkaline solution to hydrochloric acid, and methyl orange shows yellow color in alkaline form, and acidic form it shows either red or orange. So I'm writing yellow to orange color. So our answer is yellow to orange. Next sub question says, for experiment 1, compare the volume of dilute hydrochloric acid needed for the first color change with the volume of the dilute hydrochloric acid for the second color change. Now for experiment 1 it says, so let's go for the experiment 1 readings here, and we need to compare the two volumes for the first color change and for the second color change. Now if we compare these two volumes, we can say that for the second color change, double the volume of hydrochloric acid is required. So we can say that for the second color change, you can write it fully in words, but I'm writing it in short here. So for the second color change, the volume of acid required is double than the first color change. This is the answer. Main point is that the volume required is double. That's the answer. And it carries 2 marks, because if we just write more volume is required for the color change, you'll get only 1 mark. But if you write specifically that double the volume is required, then we get the second mark. So to get full 2 marks, we need to specify how many times the volume is differing for the next color change. If we be specific, we get specific full marks. So let's go ahead with the next sub question, where it says compare the concentration of solution K used in experiment 1 to the concentration of solution L used in experiment 2 and explain your answer. Now for this, again we need to compare the readings of experiment 1 and 2. Now here we can say that the difference of the second color change is 20.8, but here the difference for the second color change in experiment 2 is 31.2. Now this, you can see that it is almost 1.5 times. If you compare this one also, 10.4 difference, and here the difference for the first color change is 15.6. So you can say that the experiment 2, that is with solution L is having the concentration 1.5 times greater than the solution K. So here we can write accordingly that the concentration of L in experiment 2 is 1.5 times greater than the concentration of K in experiment 1. And it's said that explain your answer, and you can see that there are 3 marks. So 1.5 times greater of L compared to K, that carries 2 marks, and if you explain your answer, then that carries the 3rd mark. So the explanation is that the solution L required, so we can say that the solution L required 1.5 times greater volume of HCl, 1.5 times greater volume of HCl for color change. That is the explanation. On the basis of volume of HCl only, we had deduced that the concentration is 1.5 times, and that's what we need to explain also. So you can see that if there are 2 marks for one sentence, or if there are 3 marks, we need to specify specifically that how many times volume. Why? We also need to look at the questions again. It's not only the comparison of the concentration, but here the explanation is also asked. Many a times I have seen that the students skip the second part of the question. So I'll always say reread the question when you are answering, and also have a look at the marks of the question and think accordingly that for 3 marks, what 3 valid explanations we are going to write to get the full marks. Let's go ahead with the next sub question, which says deduce the volume of dilute hydrochloric acid needed for the second color change when the experiment 2 is repeated using 50 centimeter cube of solution L. If we go to the experiment 2 where L was used, we need to have a look at the question that earlier what is the volume of the K or L we had used, and here we can find out that the 25 centimeter cube of K and L was used. Now in its place, if we are using solution L as 50 centimeter cube, so we can say that double the volume of L is used. Now if double the volume of L is used in the second experiment, obviously we will need double the volume of HCl to for the color change. So if we have 31.2, then double of its solution is required. So let's specify it. For the second color change, it's written, so 31.2 double is 62.4. So we will write 62.4 centimeter cube of HCl is required. That is, double the solution is required. That is, double solution is required. Double solution is required. So that is how, as we are giving a specific volume, then we'll get 2 marks fully for it. State why using 50 centimeter cube of L would cause a problem. Now have a look, what is the volume required? 62.4. Now the capacity of burette is just 50 centimeter cube. So we need to write that the volume of HCl required, the volume of HCl required is more than the capacity of burette, is more than the capacity of burette, which is 50 centimeter cube. So that is going to create problem. Or you can write any such similar sentence of the same meaning in your own words, where the volume of HCl will exceed 50 centimeter cube. You can write such a sentence also. So everything is acceptable with the similar meaning. Let's go ahead with the second sub question, which says state the advantage of using pipette instead of measuring cylinder in these experiments. Pipette is always accurate, so you can just write for more accuracy, for more accuracy, because it will give us the accurate volume of 25 centimeter cube rather than measuring cylinder. Okay. Explain why. Next sub question. Explain why the conical flask was swirled as the dilute hydrochloric acid was added from the burette. Now that carries only 1 mark, and the simple reason is that for mixing of the solutions continuously, for mixing of the solutions, that's the only reason that we keep on swirling during the experiment, and so that we get the exact color change at proper volume. Next sub question says that at the start of experiment 1, the burette was rinsed with water and then with dilute hydrochloric acid. At the start of experiment 2, the conical flask was rinsed with water but not with solution L. Now the reason is being that if some part of solution K is left over, then it would get mixed up with L. So explain why conical flask was rinsed with water only in the experiment 2. Just we can say that to avoid mixing of the solutions, to avoid mixing of the solution. So we are just rinsing it with water. To avoid mixing of the solutions and to clean the conical flask, to clean the flask. That is what we are going to write for this question. Now next sub question says explain why the conical flask was not rinsed with solution L in experiment 2. Why? Because if we rinse it with experiment 2, then some unknown volume will also be added to the conical flask. So to avoid adding unknown volume of, to avoid adding unknown volume of solution L in the flask. That is the main reason. Now let's start with question 3. Question 3 says solid M and solid N were analyzed. Solid M was iron 2 nitrate. Tests were done on each of the substances. Now we know that solid M is iron nitrate. So we need to write the test accordingly, that we need to write the test of iron 3 and about nitrate. But solid N is unknown, about which the information will be given, and we need to find out and deduce what is solid N. So let's start with the first test on the solid M, which we know that it's an iron 3 nitrate. So let's start. It says that solid M was dissolved in water to form the solution M. Solution M was divided into two approximately equal portions in two test tubes. Now to the first portion of solution M, aqueous sodium hydroxide was added gradually until excess, and the product was kept for B. Now it says that sodium hydroxide is added. Now if we go through the cation and anion test table, which is for the cation here iron 3, then for iron 3 the test with sodium hydroxide is going to show red brown precipitates. So we can write red brown precipitates, even we can write red precipitates. So red brown precipitate I'm writing. But then the second portion of the question says that it's added until in excess, and the product was kept for B. So if it is excess, we need to write the solubility of precipitates in excess of sodium hydroxide. But for iron 3 the precipitates don't dissolve, so we can say that the precipitates stays, or we can say the precipitates remains insoluble. Anything can be written, you can write any one of it. So you can see that here there are 2 marks. So 1 mark was for the correct color of the precipitates, and the second mark for the solubility of the precipitates. Now the B part of the question says the product from A was transferred to a boiling tube, and the piece of aluminium foil was added, and the mixture was warmed gently. Any gas produced was tested. Now if you check the boiling it with aluminium foil, and the same solution for A is carried on. Now here if we continue with the same solution, then the ferric hydroxide is also formed, and the sodium hydroxide is also in excess. So that shows that we are heating the product in presence of an alkali and aluminium foil. Now if you check the test of anions, we say that if any anion is heated in presence of an alkali and aluminium foil, and if the test is given, that's a test for nitrate. You can check the table of anion, it's a test of nitrate. And what's the observation? Colorless gas will be seen, colorless gas formed, and if we check this gas, then the red litmus paper turns blue. Why? Because ammonia gas is produced. So ammonia gas changes. And the B part, second part, identify the gas made in 1. So as I already said, ammonia gas is produced which turns red litmus paper blue. So our answer lies here. The gas produced is ammonia gas. Now let's go ahead with the next part of the question, which says that to the second portion of solution M, about 1 centimeter depth of dilute nitric acid is followed by a few drops of barium nitrate were added. Now this is a test of sulfate ions, SO4 2-. Now as we know that in solution M it is iron 3 nitrate, it's not a sulfate. So here we won't get any result. So we can say that no observation or no color or no change or no precipitates. We can write anything. So here no observation because the test of sulfate won't be given by iron 3 nitrate. Now let's go ahead with the next part where test on solid N is shown. Now the next solid N, the test with the solid M is already done and we have written the observations. Now the test for solid N are given and we need to find out what is solid N. So let's have a look at all the tests and deduce that what is solid N. Now a flame test was carried out on solid and the flame becomes a red. So it's a red flame, we can say that. Now solid N was dissolved in water to form solution N, and solution N was divided equally into one test tube and one boiling tube. Test 2. About 1 centimeter depth of dilute nitric acid was followed by a few drops of calcium nitrate, and calcium nitrate were added to the first portion of solution N in the test tube. Now here there is no visible change. Now that shows that the chloride, bromide and iodide are not present. So other than that, what is the possibility? Let's have a look at test 3. Test 3 says that about 2 centimeter depth of dilute hydrochloric acid was added to the second portion of solution N and the mixture was warmed and any gas produced was tested. Here it says that acidified potassium manganate changed from purple to colorless. Now we need to understand that when hydrochloric acid is added and a gas is produced and that turns potassium manganate color, means that it should be an SO2, that is sulfur dioxide gas, and sulfur dioxide gas is produced when there is a sulfite present. So the last test 3 shows that our anion is SO3 2 minus, sulfite is there and the cation is identified here. The flame became red. Now red flame is generally given by lithium metal, that is Li+. So lithium metal and sulfite is present. So here let's go ahead with the next part. It says that identify the gas produced in test 3. Now test 3 we can say that the sulfur dioxide gas is produced. Sulfur dioxide gas, that is the gas which turns potassium manganate color from purple to colorless, that is decolorizes potassium manganate. So now what is solid N? Solid N is lithium sulfite. We can write it in word also or we can write it in formula also. So formula of lithium sulfate is Li2SO3. Now here it carries 2 marks. Why? Because we have written one cation and one anion. Suppose if you are not able to guess any one of the cation or anion, then also whatever you know, if you are able to deduce anion, just write the anion, so we can get 1 mark. Or if we are able to deduce only one cation, then also write the name of that cation, so that at least one of the mark is achieved here. If we are able to write both the ions, then the full 2 marks will be achieved here. Okay, let's go ahead with the next and very important part of the paper 6 questions. Now this is analytical, that is planning and investigation question, and it carries 6 marks. We can see that here it carries 6 marks, such a big question. So here there are many few things, many important points we need to take care. And what is that? The diagram shows some coffee beans. Here some coffee beans are shown. Caffeine occurs naturally in coffee beans. Caffeine is a white crystalline solid. It is very soluble in hot water but much less soluble in cold water. Plan an investigation to obtain a pure crystalline sample of caffeine from coffee beans. We need to obtain the crystals of caffeine from coffee beans. Now assume that all other substances in the coffee beans are very soluble in both hot and cold water. you are provided with the coffee beans and some common laboratory apparatus. So let's start writing according to the 6 marks here. Now first point which is given is that we are given the solid coffee beans. Now beans are a bigger pieces. So what we need to do is first let's start by crushing the coffee beans. So we can say that grind the coffee beans, or even we can say that crush the coffee beans. Grind the coffee beans with the help of mortar and pestle. Now we need to, as far as possible, mention all the apparatus which we are using, because we need to mention common laboratory apparatus which are given here. So with the help of pestle and mortar, I'm mentioning here. At times you get marks even if you don't mention it, but it's always good to mention. So grind the coffee beans with the help of pestle and mortar. After being grinded, what are we going to do is add water to dissolve the solids. Add water to dissolve caffeine. Dissolve caffeine. Even if the other substances which are soluble will dissolve, but that doesn't matter. To dissolve caffeine and stir. Stirring or mixing is possible. So stir. Next, we will heat the mixture. Heat the mixture again, that is to dissolve the few substances which are insoluble in cold water. So heat the mixture, and then next filter the mixture to remove out some insoluble substances if present. So filter the mixture. Next, allow it to cool down. Allow the mixture to cool down. Allow the mixture to cool. Now the reason is that the other parts, as it's already written that the other soluble substances in the coffee beans are very much soluble in both hot and cold water, but then the caffeine is soluble only in the hot water. That's what is written here. So what is going to happen is that on cooling the mixture, the caffeine will start crystallizing. So allow the mixture to cool. The crystals of caffeine will be visible. The crystals of caffeine is visible. That is how we are going to obtain the crystals of caffeine. Now what we can do is, after the crystals of caffeine are obtained, we can again filter the crystals and then wash the crystals. So filter the crystals and wash them with distilled water. Again, mentioning distilled water is very much important. Why? Because other water or any other liquid might dissolve the caffeine, which is not required here. So filtering the crystals and washing them with distilled water, to mention, is very important. Wash them with distilled water, and here are our pure crystals of caffeine. Now suppose if in any other question, if it's asked, obtain the pure and dry crystals of any given substance, then we need to again mention at the end that dry them between the filter papers. Now dry them filtered papers because we need the dry crystals. Here it's not mentioned that obtain pure and dry crystals. Here it's written only pure crystalline sample of caffeine is needed. So here we are just washing it distilled water and we are obtaining the crystals in the filter paper. So this is how we are going to write all these points. If we are mentioned that grinding, then dissolving, stirring, heating is required here, heating, then allowing it to cool down to obtain the crystals, and then filter the crystals. If some such points are written, then it's sure to get full 6 marks. Only such simple process is required here. So here is the whole paper 6-2 of May-June 2022 fully solved.